If you've been going back and forth on residential versus data center proxies for your profiles, trying to figure out which one finally keeps accounts alive, I want to reframe the question before we even get into the technical differences, because the framing itself is where most people go wrong from the start. I run real proxy infrastructure day to day, SIM cards sitting in physical modems, servers in real racks, actual carrier connections across more than one country, and I test anti-detect browsers against that infrastructure every week for antidetectbrowser.org. This isn't theoretical for me, it's what actually happens when real profiles running through real proxies hit real platforms and either survive or don't. Most people asking residential or data center are really asking which one stops their accounts from getting banned. Neither one does that by itself, and I wish I could tell you it was that simple. A proxy is just one input into a much bigger picture a platform builds about a browser session, and once you run enough profiles for long enough, you learn the IP matters less in isolation and more in how well it lines up with everything else the profile is presenting to the platform. Still, the IP layer is where a lot of detection starts, so before you spend money on either category, it's worth actually understanding what separates them under the hood, instead of just repeating whatever advice you read in a forum thread from someone who ran free accounts and got lucky. A data center proxy is an IP address assigned to a server sitting in a hosting facility somewhere, AWS, OVH, Hetzner, or a proxy-specific hosting provider. It honestly doesn't matter which one. These IPs are registered to a hosting AZN, and that registration is public information anyone can pull up. Anyone running a Whois or AZN lookup on an incoming connection can see in seconds that it belongs to a hosting company rather than to a residential ISP like Comcast, StarHub, or Vodafone. Data center IPs also tend to sit in large, contiguous blocks that hosting providers buy in bulk to resell. Once a platform's trust and safety team flags even a handful of IPs inside one of those blocks as abusive, it becomes cheap for them to deprioritize or challenge the whole block at once, instead of chasing individual addresses one by one, because that's a far more efficient use of their own moderation budget than investigating each connection on its own merits. That's exactly why a fresh data center IP can work perfectly fine for a while and then suddenly run into harder scrutiny with no warning. It's not that the specific IP did anything wrong, it's that its neighborhood did, and you inherited that reputation the moment you were assigned it, through no fault of your own. A residential proxy routes traffic through an IP that an ISP actually assigned to a home or a mobile connection, usually through a consumer device that's opted into a proxy network in some way, a phone with an SDK installed, a home router, or a modem pool like the ones I personally run on real SIM cards. The SN behind that IP belongs to a telco or an ISP, not the hosting company. And that distinction alone changes how a lot of risk engines score the connection before anything else even runs. Mobile residential IPs add a whole extra layer on top of that. Carriers run large-scale CNET, so hundreds or even thousands of subscribers can be sharing the exact same public IP at the same moment. And that IP gets rotated across those subscribers by the carrier's own infrastructure, not by whoever is selling you the proxy. You don't control that rotation, and neither does your provider, no matter what their dashboard promises. That shared carrier churn nature is exactly why mobile and residential IPs read so differently to a detection system compared to a data center one. The IP carries a plausible history of ordinary consumer traffic, normal browsing, app traffic, everything a real subscriber does day to day, all mixed in with whatever proxy traffic happens to be riding along on it at the same time. Here's the part most "just buy residential and you'll be fine" advice conveniently skips over. Detection isn't one signal, it's a whole stack of them working together in the background, layered so that no single check has to carry the whole decision. Platforms buy commercial IP intelligence data, the same kind of data that feeds fraud filters, ad networks, and banking risk engines, and every single IP gets tagged as hosting, residential, mobile, VPN, or proxy before anything else about the session even gets evaluated. A data center SAM is a point against you before the platform has looked at a single click you've made, and that score follows the connection into every later stage of the check. But the IP type only buys you a better starting position. It never buys you a pass on its own. A residential ISP IP that behaves like a script, perfectly timed requests, zero mouse movement, an identical session shape repeated across thousands of supposedly different accounts, still gets flagged, and I've watched it happen in my own testing more than once, sometimes within the first day. The IP type shifts the platform's prior assumption about you. It doesn't override whatever behavior is sitting on top of it. Both categories can burn out over time too, just at different speeds. A residential IP is only ever as clean as what that SN's traffic looks like, on average across every single user sharing it. If a specific proxy pool gets resold and abused by enough people, its residential IPs build up the exact same kind of bad reputation data center ranges accumulate. It just takes longer because the pool is bigger and the IPs churn more often underneath it, hiding the damage for a while. And this is exactly where the proxy choice actually connects to the anti-detect browser sitting on top of it, which is the part I spent most of my actual testing time on. A profile's IP implies a geography, a time zones, a language, and sometimes even a specific carrier. If your proxy resolves to Singapore, but the profile's time zones, locale headers, and website leak all point somewhere else entirely, that mismatch is a far bigger red flag than the IP type ever was on its own, and platforms weigh it heavily. Multilogin, GoLogin, Camelio, Adds Power, and Dolphin Anti all let you set canvas, WebGL, time zones, and language per individual profile. And I've gone through that control surface in every one of them on real accounts, not just in a demo. None of them auto-correct that data to match whatever proxy you happen to plug in, not one of the 5. You have to do that matching yourself by hand. And in my testing, a lot of banned accounts trace back to someone skipping that one step rather than to the proxy category itself being the wrong choice. I've seen it happen the exact same way more than once. Someone buys a clean mobile residential IP resolving to one city, drops it straight into a fresh profile, and never touches the time zone or language settings the browser shipped with by default. The account survives the sign-up, sometimes survives a week or two, and then gets flagged the moment the platform's behavioral layer cross-checks the locale data against the IP and finds a story that doesn't add up. Datacenter proxies fail fastest on platforms that check IP type directly as part of their risk scoring. Most social platforms, most ad networks, basically anything with a real fraud budget sitting behind it. Their upside is genuine though, and I don't want to pretend otherwise. They're cheap, fast, and stable, which matters a lot for workloads that aren't trying to pass as an individual consumer at all. Scraping jobs, internal tooling, testing environments where nobody's pretending to be a person. Residential and mobile proxies fail in a completely different way. They cost noticeably more, and some low-quality residential pools are built on STD lightly bundled into free VPN apps or utility apps where the end user never clearly agreed to have their home bandwidth resold to strangers browsing through it. That's genuinely worth knowing before you pick a provider, entirely separate from whatever it ends up doing for your band rate, because it changes who you're actually paying and what you're paying for. Session stickiness is a real, recurring problem on the residential side that catches people off guard. Some pools rotate the exit IP mid-session because the underlying subscriber's phone changed cell towers, or because the carrier silently reassigned the CHNAC pool underneath them. That can break a login session in ways that look deeply suspicious to a platform, even though nothing you actually did caused it. VIPO IPSes carry a strange asymmetry I've personally watched play out both directions. Because so many real subscribers share one IP at once, platforms are sometimes more forgiving of a single mobile IP behaving a little oddly, since it might just be ordinary carrier noise. And other times they're less forgiving, because mobile IPs are also the single most heavily abused category out there, for exactly that same reason. So some risk models weight them with extra suspicion by default. For multi-accounting specifically, the property that matters most isn't the residential label sitting on a checkbox somewhere, it's whether the same profile keeps getting the same exit IP across a session, and ideally across return visits too. A platform building a device or account graph is watching IP plus fingerprint stability over time, not reading a category name off a sales page. A profile that logs in from one IP on Monday, a different one on Tuesday, and a third one on Wednesday, with no plausible travel story behind any of it, builds a noticeably weaker trust signal than one that holds a single consistent IP for the whole life of the account, even when that consistent IP happens to be a data center one. The graph doesn't care what the IP is labeled. It cares whether the pattern looks like a real person's life or like an operation. That's exactly why, in my own setups, running dedicated ports, one modem or one line pinned permanently to one profile behaves so differently in practice from pulling out of a rotating shared pool, no matter what label that pool is sold under. Consistency beats category almost every time I've tested it head-to-head, across every browser I've put through this. So here's the practical way I actually decide this for myself. If the workload doesn't need to look like an individual consumer at all, I don't pay residential prices for it, full stop, it's just wasted budget. If it does need to look like a person, the proxy type is necessary, but it's never sufficient on its own. Pin one IP per profile for as long as you possibly can, and match that IP's geography to every other locale dependent setting inside the browser profile. And even a genuinely well-matched setup can still get flagged if the platform's behavioral checks don't like what the session actually does once it's logged in. No proxy category and no anti-detect browser removes that risk entirely. I wouldn't say that about any tool I've tested, and I'd be skeptical of anyone who does. They only change which signals a platform has to work with, not whether it's evaluating you in the first place, and anyone telling you different hasn't run enough profiles to find out. I test these browsers on real multi-account setups, so the written reviews and the picks I actually trust are all at antidetectreview.org. Filmed copies and tested picks at antidetectreview.org. Go take a look and subscribe if you want the next one when it's out.